Let's consider this integral here. We've got e to the x sine x, and we want to use integration by parts. So, first of all, I'm going to let u equal sine x, and then du, of course, will be cosine x dx. Okay, and then dv is the rest of it. So it's e to the x dx. That means that v is equal to e to the x. So that's pretty easy start. Now, let's see what happens. Remember the formula is uv. So here we go, uv. So this is e to the x sine x. That's uv minus v du. Okay, so we get e to the x cosine x dx. Okay, so we've used integration by parts, and notice this integral here is just as bad as this one. Okay, so we're going to use integration by parts again. Okay, so I'm going to take this integral right here, e to the x cosine x, and this time I'm going to let u equal the cosine. I'll call this u1. u1 equals cosine x, and then du1 equals negative sine x. And we'll keep the same dv. dv is equal to e to the x, and v, well, dx, and v is equal to e to the x. Okay, so let me do this one. So now we have uv. So this is e to the x cosine x. See, uv minus v du. So this is negative e to the x sine x. See, so v du, there's an extra negative in there. I just put it there with that negative. Now these two negatives here are going to make a positive, but you notice we're kind of back where we started. So let's put all of this together. Here's where we started. We had e to the x sine x dx equals, now go back up here, right? This is e to the x sine x, okay, minus, but instead of this integral here, I'm going to put what it is down here. So let me just open a bracket, and I have e to the x cosine x, see, plus e to the x sine x integral in the integral. See? So all I did was, in place of this integral right here, in place of this integral right here, I just put all of this. And there we have it. Now, let's keep going with this, and you might think, why? We're stuck, but be patient, and I'll show you. So here we have e to the x sine x minus e to the x cosine x minus e to the x sine x dx in the integral there. Okay. Now, here's what we want to do. Notice we've kind of made a round trip. We started with e to the x sine x. We went through integration by parts a couple of times. And notice we've got e to the x sine x, and we're right back there. But notice, just thinking about algebra, we've got this and this. Why don't I just add this to both sides? E to the x sine x. These are like terms. So dig this. We've got 2 e to the x sine x, okay, equals e to the x sine x minus e to the x cosine x. Now, if I just divide by 2, I'll have it. That'd be it, right? Because look at this. E to the x sine x equals. This is what we wanted to know. We wanted to know, what does that equal? Well, here it is. It's 1/2 e to the x sine x minus e to the x cosine x. Yeah. And then we'll throw in a constant. Yeah. Well, that's what we wanted. That's not the way we're accustomed to thinking about finding an antiderivative, but that works. And I call this round trip. I don't know what the official name would be, but we're making a round trip. We're starting here. We're integrating by parts a couple of times and getting right back where we started, and then we're using our algebra.